In here, we're going to talk about several sampling techniques. First, consider these two scenarios. 1. 100 students at Central High School are selected at random and asked how many hours per week they spend on homework. Their GPAs are recorded, and the researchers see a moderate, positive, nonlinear association between homework hours and GPA. 2. 100 students at North High School are selected at random and divided into two groups. One group is assigned to 60 minutes of one-on-one tutoring during a free period, and the other group is assigned to a supervised study hall during a free period. After 1 month, researchers observed that the percent of tutoring students who are failing one or more classes is less than the percent of study hall students who are failing one or more classes. So think about these two scenarios. Which are census and which is census and which is sampling? Or think about, is there any experiment involved or simply observational study? And we're going to dive deep into it. So first, I want to introduce several methods for obtaining a group of individuals. First, census. It means a survey of every member of the population. Second, sampling. Survey a subset or sample from the population. And for population and sample, they have different parameter and statistic. For a population, we usually call it parameter. For a sample, we usually call it statistic. And the listed symbols right here are the common symbols you will see for different statistical method. So just take a glimpse at it. We won't worry about it too much as of for right now. And we're gonna also think about some poor sampling choices. So some of the sampling choices may not be appropriate if we want to get a correct data. Some may lead to bias, and here are a couple of those. First is voluntary response. It's subjects volunteer to participate. It will definitely lead to bias. For example, if you put a online survey, and any people who are interested in can fill it in and turn that in, it will definitely lead to a bias because we don't know the reason that led to the people who choose not to respond, maybe due to what reason, right? Maybe that reason is related to the subjects we're talking about, and the data is very important. And the voluntary response is also important because people who voluntarily involved in that event or that statistical experiment, maybe due to several reasons, they are already familiar with that thing, and that will also lead to bias. We cannot guarantee our assigning group is completely random, so therefore it's not reliable. And next one is convenient sampling. It's convenient to the experimenter. So for example, if I stand on the next to the door of a classroom, and I record the response for every classmate entering that classroom just for that class period, well, that will definitely lead to convenience to myself, but the data I collected is not random and it's not reliable either, because like the sampling, like again, the assigning group is not random, and yeah, so we want to try to avoid that when we're doing our experiment. But those are the poor sampling choices. We also have good sampling choices. So the characteristics of good sampling choices are the following. First is randomization. So just as I said before, you want to make your experiment group as random as possible. It will reduce bias. Second is bias on experimenter or subject. So that will lead to some of the experiment, they will probably be blinded experiment. So what is blinded experiment is the people who involved in that experiment don't know they're actually doing an experiment, and the people who implement that experiment also don't know. Like some of the factors been blocked. That's also a way to reduce bias, but like the bias on an experimenter or subject will definitely lead to some deviate response for the real from the real value. So third one is generalization. Results can be used to describe overall population. So that's the goal for our good sampling choices, because for a generalization, after we obtain a result or a data value from our experiment, we want to make sure that it's a good representative for the population or the experimental groups that we're examining. It's a good representative for both. So that's the main idea of generalization. And we also have different sample types. First one is simple random sample. This is simply means every sample of size n has the same chance of being selected. It can also be shortened as SRS. So what are some method or what are some ways that we can implement a SRS? Well, we can name the name from each people, like put their names on the spinner using a random number generator, or using rock, paper, scissors, straws, or popsicle stick, or deck of cards, die, or coin. Those are all of the things that will help us to get a simple random sample. Second one is stratified random sample. This means that subgroups in population include every random, like subgroups in population for each group. And I will talk about it later. It's basically the simple random sample for every subgroups that we divided in for a whole population, and we're doing a simple random sample for each subgroup. We collect the results from each subgroup at the end and doing a overall examination and get a real result from it. And the third one is systematic random sample. It's basically you're trying to find a pattern for the group that you are taking the like you're implement experiment on a group of people who have the same pattern. For example, if I only want the odd person, like I number each person with a random number generator, and I only want to collect odd number person. So that will be an example for systematic random sample. A cluster sample is similar. It's very similar with clusters in cluster sample is very similar with stratified random sample, and it's also a confusion for a lot of people. But cluster sample, the main idea behind it is you assign similar clusters in population and you random pick some clusters. So because each of the clusters, they share some similarities, and so if that similarity is just the characteristic we want examining, then it doesn't matter what cluster we pick on. We can just randomly pick some clusters and survey everyone in the cluster. And basically, we're doing a simple random sample from that cluster using a multi-stage method. So yeah, that's the main idea behind cluster sample. Okay, so that's the 4 different sample types introduced in here. So in this video, I just want you to have a good idea about what is a sampling versus census, what are some poor sampling choices, good sampling choices, and what's the sample types, and how do you identify each. So I hope you learned something from this video. If you do, please like and subscribe. Thank you so much for watching. Oh, and if you can right now have a good idea about those sampling methods, feel free to look at the beginning example I provided here and think about the answers in your head. Feel free to leave comments below. Thank you.